Hi dear students, we are in the session 8 of Elasticity chapter. In this session, we are going to discuss the problems on elasticity and some of assignment questions. After the completion of this session, you will be able to know the data given in the problem, which formula should be used to solve the problems, how to solve the problems, and about assignment questions. Let us discuss the problems one by one. Find the amount of work done in twisting a steel wire of radius 1 mm and length 25 cm through an angle of 45 degree. Given rigidity modulus for steel is equal to 8 into 10 power 10 Newton per meter square. In this solution of the problem, we have to first write the given values. Here given values are A, radius of the wire. A is equal to 1 millimeter. It is equal to 1 into 10 power minus 3 meter. Convert millimeter into meter. Then length of the wire is 25 centimeter. Convert centimeter into meter. That is 25 into 10 power minus 2 meter. And theta is in degrees, and convert the degree into radian. Therefore, theta is equal to 45 degree into pi by 180 radians. It is equal to pi by 4 radians. And n is equal to 8 into 10 power 10 Newton per meter square. The amount of work done or strain energy in case of twisted wire is given by W is equal to half C theta square. It is equal to half. The value of C is pi n a to the power of 4 by 2L. Substitute that value here. Then theta square as it is. Then substituting all the values in the equation, we have W is equal to half pi 8 into 10 power 10, that is actually 8 into 10 power 10, and radius is 1 into 10 power minus 3 to the power of 4 divided by 2L, 2 into 25 into 10 power minus 2. Then theta square is pi by 4 square. And after simplifying this, we have W is equal to 0.154 joule. And right here it is 10 power 10. This value is missing here, 10 power 10. Okay. Then the next question, next problem. What force is required to stretch a steel wire 1 square centimeter in cross-sectional area to double its length? Given Young's modulus Q is equal to 2 into 10 power 11 Newton per meter square. Here given values are A is equal to 1 square centimeter or Q, and Q is equal to 2 into 10 power 11 Newton per meter square. For double the length means delta L is equal to L. Here you see delta L is equal to L for double the length. Therefore, delta L plus L is equal to 2L. Then the equation for Young's modulus is given by force per unit area in the numerator, in the denominator, the strain, change in length to the original length. Therefore, F is equal to QA delta L by L. Substituting values, the value of Q is 2 into 10 power 11. A is, area is already given here, 1 square centimeter. Convert the square centimeter into meter. Therefore, we have 1 into 10 power minus 4, and delta L and L are equal. Therefore, they are cancelling each other. Then we have finally the value F is equal to 2 into 10 power 7 Newton. Then the next problem is calculate the Poisson's ratio for the material. Given Young's modulus Q is equal to 12.25 10 power 10 Newton per meter square and rigidity modulus N is equal to 4.55 10 power 10 Newton per meter square. Here given quantities are Q and N. We have to calculate sigma, and we know that the relation between Young's modulus, rigidity modulus and sigma is given by N is equal to Q by 2 into 1 plus sigma, or sigma is equal to Q by 2N minus 1. Substituting the values here, Q value is 12.25 10 power 10 divided by 2N, 2 into 4.5 10 power 10 minus 1. Then the value is N is equal to 1.346 minus 1. Therefore, it is not N, it is sigma actually. Sigma is equal to 0.346 and it has no unit. In another problem, a wire of 3 meter long and 6.25 10 power minus 5 meter square in cross sectional area is found to stretch by 0.3 centimeter under a tension of 1200 kg. What is the Young's modulus of the material of the wire? Here given quantities are length of the wire is given, it is 3 meter and area of cross section is 6.25 10 power minus 5 meter square. The change in length is 0.3 centimeter. The M value is 1200 kg and we have to calculate the Q. The expression for Q, Young's modulus, is equal to, in the numerator we have stress is force per unit area. In the denominator we have strain is change in length by original length. Therefore, it is equal to FL by delta L into A. Then we can write F is equal to M into G. Therefore, we have MGL by delta A into A. Then substituting all the values here, M is 1200 and G is 9.8, L is 3 divided by delta L is 0.3 10 power minus 2. Convert this centimeter into meter. Then A is 6.25 10 power minus 5. Then after calculating, we have the final value for Young's modulus. Q is equal to 18.816 into 10 power 10 Newton per meter square. Okay. Then the assignment questions. The two most questions in this chapter: elasticity. State and explain Hooke's law. Define Poisson's ratio and what are its limiting values. Obtain the expression for elastic potential energy. Obtain the differential equation for torsional oscillations. Write the expression for period of torsional oscillations and mention the terms. These are the two most questions. Then let us discuss the 8 most questions. Derive the relation among the elastic constants. Obtain the expression for bending moment. Derive the expression for depression at the loaded end of the cantilever. Derive the expression for couple per unit twist of a cylinder. These are some of the reference books. Thank you.